In this lesson, we're going to examine some of the ideas and go over some of the concepts from grade 9 that we need in order to look at our next unit, which is called analytic geometry. Some of the big ideas are about the equations of lines. For us, the equation of a line is given by y equals mx plus b. M is our slope, and b is our y-intercept. And we'll talk about slope first. Now, when we want to find our slope, there's two ways we can go about doing it. If we have a diagram, we can use our rise over a run. We can just count. And just be careful that you work from left to right. So if you have to go up, it's a positive rise. If you go down, it's a negative rise. We always go left to right. If we don't have a picture, then we use our formula. y2 minus y1 and x2 minus x1. The y's are your up and down direction, which is your rise, and the x is your left and right direction, which is your run. It's just a different way of approaching it. So look at the first example here. Determine the slope of the line joining A and B. So I'm going to write this down as M and then subscript AB, so slope of AB. Now I have a picture, so I can count. To go from A to B, I have to go up 1, 2, 3, so a rise of 3, and a run of 1, 2, 3, 4, 5, 6, 7. There's my slope. That's it. I'm done. If we try letter B, I don't have a picture. It won't fit in my graph. I got to use a different way of approaching this. So my slope of AB, we're going to use our formula this time, this one. So each point is made up of an x and a y. X and a y. We could call this our first set. We could call this our second set. So if I do y2, that'd be number 7, minus y1 is negative 5. x2 would be 1, minus x1 would be 3. And just be careful that you're going in the consistent order. So I did 0.2 minus 0.1. On the top, 7 minus negative 5 is 12. On the bottom, 1 minus 3 is negative 2. And I'll simplify that by dividing this time. And I get a slope of negative 6. If I were drawing this, my graph would go down from left to right, because it's a negative. Okay, so we have to be able to calculate slope. That's one of our ideas. There are some relationships we should know about between lines. Now, we've talked about this last unit when we talked about linear systems. For instance, parallel lines never crossed. And they never cross because they have the same slope. The word we want to add to that is perpendicular. And we're going to use this upside down T symbol for perpendicular. With perpendicular lines, you have two slopes again, but these slopes are negative reciprocals. And that means they have opposite signs. That's what negative means. And they're reciprocals, which means they're flipped over from each other. So if I look at this example here, my slope number 1 is 3 over 1, and it's a positive 3 over 1. When I flip that over, I get the opposite one, negative 1 over 3. So these two things are negative reciprocals. They are perpendicular. I flip it over and I change my sign. Some other examples of negative reciprocals that you might come across. So let's say I had a slope of 2/3. It's negative reciprocal, and the way we'd write that is m perpendicular. I flip it over, and I change my sign. Now notice I'm only changing one of the signs, because the entire fraction is either positive or negative, so only pick one. Okay, so some relationships. Next idea, we want to be able to write the equations of lines. And by equation, we mean y equals mx plus b. We can write the equation if we know the slope and the y-intercept. All we got to do is fill those two things in. So if we look at the first one here, find the equation with a slope, oh, there's m of 2/3, and a y-intercept, oh, there's b of negative 6. Our equation will be y equals m 2/3 x plus b, and b is negative 6. That's what we need. Now, we're not usually going to be just given the information. We're going to have to calculate it, figure it out, identify it. So we'll try a couple here. Find the equation of the line that's perpendicular to this line. Well, perpendicular means it has the opposite slope. So this slope is 2. So the perpendicular slope, if I flip it over, think of it as being 2 over 1, it becomes 1 over 2, and it's negative. So it needs to have this slope, and it has to have the same y-intercept as this thing. That's a form that's not nice for us to figure out the y-intercept. It's not in the right order. So let's change the order. Let's put into y equals mx plus b. Let's rearrange it. So the first thing we're going to do is rearrange it. Let's bring that 3x over. It becomes negative 3x and then plus 6. But we don't want negative 2y equals. We want y equals. So we're going to divide everything by negative 2. And we'll end up with y equals, 2 negatives make a positive, so 3 halves. And 6 divided by negative 2 is negative 3. I was doing that so I could identify the y-intercept. There's the y-intercept. So we need a line that has a slope of negative 1/2 and a y-intercept of negative 3. So we can write that in as negative 1/2 x minus 3. We had to gather information that time by finding out relationships between things. Let's look at the next set. We have a picture. Find the equations of the lines given below. We said the nice thing about pictures are you can count on them. If I want to find the equation of the green one, I have to figure out my slope. So I can do that by counting. To go from one nice dot to another nice dot, I have to go up 1, 2, 3, 4. That's my rise. And over 1, 2, 3, 4, 5, 6. There's my slope. My y-intercept I can see on the graph. It's right here where I cross the y-axis. That's a plus 1. There's the equation. Done. We like graphs. They're helpful tools. Our line we're going to use in this unit is when in doubt, draw it out, because it makes it easier to see things. Let's try the next one. 2 nice points. I have to go down 1, 2. So it's down. I have to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my y-intercept is right here at negative 2. Okay, now, if you decided I don't want to use that fraction, I want to use this one, that's the same thing. I'd be totally fine with that. If you went for just down 1 and then over 5, it's just a simpler version of 2/10, right? Okay, let's try writing the equation in line using a little bit of algebra. So we've looked at graphing, we've looked at finding relationships. Let's look at an algebraic method. So if we know the slope and a point on the line, we can find our equation by substituting into the equation using your slope and your point. So for example, write the equation of a line with a slope of 3 that passes through negative 1, 4. So I want this. What do I know? Oh, I know m is 3, so I can fill that in. Only thing I'm missing is the b. I can figure out the b if I know an x and a y, and I do. A point is made up of an x and a y. So I'm going to put 4 in for y and negative 1 in for x and solve for b. 3 times negative 1 is negative 3. We're going to move it up here. Rearrange it, so bring the 3 over, it becomes a positive 3 now, adding 3. 4 plus 3 is 7, so our equation, y equals 3x plus 7. You can always solve for it if you know parts of the information. Let's try another one. Write the equation of the line perpendicular to this and passing through a point. So I have to think about the word perpendicular. That means the opposite slope. But the problem is I can't see the slope right now. It's in the wrong order. We want mx plus b. So let's fix this one. 2y equals negative 3x plus 5. Rearrange it. Then let's divide it. And we'll get negative 3 halves x plus 5 halves. The slope of this one is right here. But that's not the slope of our line. We want the perpendicular slope. So let's take the negative reciprocal, flip it over, and change the sign. This was negative, so the new one is a positive. Now what do we know? We know the slope is 2/3. We don't know b. We can find b, though, if we plug in a point. We know a point. 4 for y, and negative 3 for x. So you can use your calculator, use your fraction button, or fractions go straight across, and we'll get negative 6 over 3, and negative 6 over 3 is just negative 2. So we can solve this. 4 plus 2 is b, so 6 is b, and now we have our equation. y equals 2/3 x, and b is 6. Okay, so we're looking at some relationships here, but we're also solving things in this one. So you got both things going on in this question. We can take this a step further if we have 2 points. The only difference between having 2 points is that we have to calculate the slope first. And we can use our slope equation to do this. So we're looking at that y2 minus y1 thing again. Okay? After you find your slope, it's the same question all over again. So let's look at this example. We've got 2 points, and I want to find the equation of the line that goes through them. So I'm going to find the slope of the line that goes through them, the slope of r to s. So y number 2 is -5 minus y number 1. X number 2 minus x number 1 will give me -8 over +8, which comes out to -1. Well, now, if I want to make this equation, I've already figured out the m part. I can fill that in. To find b, I can use either point. You pick which point you want to use, point 1 or point 2. I'm going to use point number 2, the s. So the y value is -5, the x value is 1. I want to solve for b. So at this point, it's the same stuff we've been doing. Get rid of your bracket, rearrange it, put them together, and you got your b. So our equation is y equals -1x minus 4. Okay, so 2 points in some ways is actually easier than 1 point. It's a little bit easier to think about. Okay, last idea. We have some special lines. The 2 special lines we have to worry about are vertical lines and horizontal lines. Vertical lines are weird because they have an undefined slope. You can't actually calculate them. There is no run. You get a number like 10 of rise, but no run. So because they're so weird, they have weird equations. Their equations are always in the form x equals, and then some number. Horizontal lines, also a weird one, have a slope of 0. And they have a no rise, but a run. So we just say it comes up to 0. These equations have just an equation, y equals, and again, just a number, because there's no slope. You get y equals 0, x plus something. Well, 0 times x is nothing. So we just get that number part. Okay, so let's look at an example here. Determine the equation of the line that passes through -5 and 6. That is vertical and horizontal. So let's draw that. -5, 6 is here. A vertical line that goes through it has to go through -5 and 6 to this point right here. Well, what is that point? That's where x is -5. So the vertical line is just x equals -5. The horizontal line, that would look like this. Well, what point would it go through? It goes through right here, right? 6. So its equation is y equals 6. We like horizontal and vertical actually because they're really quick to find. All you need is the x part for the vertical or the y part for the horizontal. Okay, last example. A line passes through 2 points. Find the equation of this line. And let's do what we've been doing. I've got 2 points. Let's find my slope. 5 minus 5, 17 minus -3 gives me 0 over 20. Well, 0 over 20 is just 0. Hey, that's a special line. That's a horizontal line. Horizontal lines are y equals. Now, I can solve it like I've been doing, plug in a point. Let's pick this point. So 5 for y, 17 for x. What's 0 times 17? Oh, it's 0. So b is 0. In other words, my equation is y equals 5, which you kind of could have cheated and noticed that you had 5 and 5. They're both the same. Okay, last part, find a perpendicular line to this. Well, the thing you have to think about here is that part A is a horizontal line. So a perpendicular one would have to be a vertical line. What's the equation of a vertical line? X equals, right? What number does it equal? Well, in this case, it's your choice because you can pick any vertical line you want to because they're all perpendicular to that horizontal one. So for random, let's pick 3. As I said, you can pick any number you want to. It's your choice. Okay, so that's a whole bunch of stuff from grade 9 we just reviewed. Try the handout that comes along with this. Chance to practice some of this stuff. And then we're going to start using it to do new things.